Welcome to EGME-331 Solid Mechanics. In this video, we are going to review factor of safety. So before we talk about factor of safety, let's understand what's safety in engineering. As always, engineers seek to produce things that are strong and that can perform the intended function. However, to achieve safety in design, it needs to withstand the extreme loads that it would be subject to over its period of life. The best practice used in engineering is to use the concept of reserve capacity so that even in the case of an extreme load event, the structure does have the ability to withstand the not so usual load or the not so originally anticipated load that was calculated during the design. Now the big question here is how safe is safe? That means we are trying to give an extra strength or extra material for the body to withstand that extra or unexpected load. If you don't provide that extra support, the material probably would fail. The structure would result in failure. Now the decision that the designer has to make here is how much extra or the factor that needs to be considered while designing the structure. So let's say we give too much reserve capacity to the structure to make it stronger. It is consequential that the material or the structure would be very expensive to manufacture. At the same time, it may be extremely heavy and bulky to handle. So the best practice here would be to strike a balance between the giving the extra strength and the cost aspect and the weight and all other considerations. So there are several factors that needs to be thought before over designing a structure. In mechanics, there are two design philosophies that are used most popularly. This includes the allowable stress design and the load and resistance factor design. In this video, we will be discussing about allowable stress design approach. So in case of allowable stress design, we have to think about failure. We need to decide what is failure for a particular structure. So is it the yield point? If the material crosses yield point, that means it incurs a permanent damage, or is it the fracture where it ultimately breaks apart into two pieces or it just collapses. So we need to decide that. Now the question here is which failure criteria are we using while we decide the factor of safety or that additional factor. It could be either or. The correct answer is it could be the yield stress or it could be the ultimate tensile strength, depending on the particular application. Now in the case of allowable stress design, the ASD method, it focuses on the loads that exist at the normal conditions. So we don't think about the abnormal conditions while we design. We only consider the loads at normal conditions. And this could be the service loads or the things that are expected to occur. So it's not the unexpected, it's just the expected loads that the material or the structure would be subject to during its lifetime. So now that we have determined the expected loads that the material would be subject to in the ASD, allowable stress design method, what we do here is we consider a fraction of the yield stress. So yield stress is the point at which the material would be subject to yielding. So we consider a percentage or a fraction of the minimum yield stress, and we term that stress as the allowable stress. So in this figure, you could see the allowable stress is lesser or below the yield stress value. So if you maintain the regular load within the allowable stress, the lower number, what we could understand is we have a reserve capacity over the allowable stress and less than the yield stress that the material could be subject to in case there is an unexpected load. So if you want to define factor of safety, it is simply the ratio of the sigma, the stress at failure, divided by the allowable stress. In case of shear stress, it will be same concept. It will be the shear stress at failure over the allowable shear stress. Now the failure can be defined several ways. As I mentioned before, you could consider failure as the ultimate failure, the actual fracture, or even a small amount of yield stress. A load condition that exceeds the yield stress of the material can also be considered as a failure. So there are different ways people could interpret failure, and depending on that interpretation, you have to decide the structure with the necessary factor of safety. Now the question here is which failure criteria are we referring to, or which failure point are we referring to? Is it the yield point or is it the fracture point? So if it is the yield point, we use allowable stress with respect to the yield stress. If it is the ultimate tensile strength or the fracture stress, we have to adjust the factor of safety depending on that stress value. The typical numbers of factor of safety are between 1.5 to 3. You could increase that number. Again, it goes back to the question of over designing or unnecessary addition of material as well as expense to the structure. Most importantly, the concept of factor of safety doesn't have to be limited to stresses alone. So it could be a force, it could be anything, in any instances or an engineering application where you have to determine a threshold. So we always, even in our life, we think about time and we give a factor of safety for the time that is available. So always the factor of safety concept can be applied at various instances, which will be nothing but the failure if that thing goes completely wrong versus the actual thing that you would consider providing. So that ratio is what we call as the factor of safety. Let's take a look at a small problem to illustrate the concept of factor of safety. Here you could see a stainless steel alloy bar which has a dimension of 25 millimeter by 16 millimeter, and it is subject to an axial load along its axis of 145 kilonewtons. Now we are asked to determine the factor of safety with respect to the yield strength. Here yield strength is defined as 0.2% offset, and the factor of safety with respect to the ultimate strength or ultimate tensile strength. So we are asked to determine two different factor of safety here, one with respect to the yield strength and the other one with respect to the ultimate tensile strength. So we are given the conditions, the yield strength as well as the ultimate tensile strength. From the figure, by using the 0.2% offset method, we can determine the yield stress as 550 megapascal. If you calculate the area, it will be 25 millimeter multiplied by 16 millimeter, and take the ratio of the force over area. The applied force is 145 kilonewton. Change the units consistently, and you could get the normal stress on the body or the bar would be 362, which means the actual stress or the allowable stress would be 362. The yield stress will be 550. The ratio of yield stress to the actual stress, the factor of safety, would be 1.5 in this case. And for the ultimate tensile strength, from the figure we could see the ultimate tensile strength sigma u or UTS is 1100 megapascal. Take the ratio of 1100 over 362 and we get a factor of safety of 3.03.